Hello again, my name is antimatter and I'd like to talk to you about time. This is the second in a short series of talks talking about the two dimensions of time and how by assuming there are two dimensions you can explain a lot of things around us quite simply. And in this second talk I want to cover the subject of matter and antimatter. It's known that every particle of matter has an antiparticle, so electrons and positrons for example, and those particles are identical except that if they meet they annihilate each other. So you can imagine here this can be what we call matter, my bottle of rice wine. If it meets another particle of antimatter, right, they're quite happy when they're separate. They can come together quite slowly in space, but when they meet they annihilate each other as if they met at the speed of light. Now that's quite consistent with our theory of time. As you recall, we postulated that in this four-dimensional space-time, everything, including this bottle of rice wine, is travelling at constant speed, the speed of light. So when the bottle's stationary, it's moving this at the speed of light, and that's represented by this roll of wrapping paper. It's a constant speed, and if it's moving at the speed of light through space, then it's not travelling through time at all. So there's a constant speed in the four dimensions. The only difference is the direction in the four dimensions that the particle, or this case a bottle of rice wine, is travelling. It's coming through space and time. It'll be moving in both dimensions. So it's quite simple to explain antimatter. Antimatter is the same particle that's moving backwards in time. Everything we know moves in both directions, can move in both directions in space. Why should it not be able to move in both directions in time? It seems obvious that it should. So if this particle, right, is travelling forwards in time, we'll call this a forwards dimension, right, at the speed of light. If it meets an antiparticle, right, coming in the opposite direction, right, at the speed of light, they will annihilate each other. Now we can't see that time dimension, right? As far as we're concerned, these things are just perfectly happy adjacent to each other. And when they meet in space, not travelling at any speed, they annihilate each other. And that's because they are travelling at the speed of light in opposite directions, and that's the reason why you get such a cataclysmic annihilation. Now the interesting thing, which is also supported and easy to explain, is why is it that while every particle has an antiparticle, right, photons and all force particles don't. We just have photons. That's really quite simple to explain in this theory, because light travels at the speed of light through space. So in doing so, it's travelling through space at the speed of light, so it has no speed through time. So light doesn't travel through time. And so as such, it's not possible for it to have an anti-proton or antiparticle, because there isn't anything to collide with. It's just travelling not in the direction of time, and the same thing can't happen. So that's quite a simple explanation of why photons and force particles don't have any antiparticle. Okay, quite simple. Occam's razor. Is it true? Well, let's explore what else we can predict with this theory, and there'll be a couple other talks.